In this video, we are going to talk about exponents, how to write them, how to read them, and how to solve them or find the value of them, because they're classified as expressions which are math problems that have numbers and operations, but it says nothing about an equal sign, so we don't classify it as an equation. So let's talk briefly about what an exponent or the operations of an exponent look like. The most common one that I will write, usually with a 5, because 5 is a good multiple, easy to multiply, and I'll do it to the third because it's not too big. So this is 5 to the third power, or we can call it 5 cubed. So 5 cubed, or 5 raised to the third power. So let's talk about what that means, what each of these parts are. Now, when you read 5 raised to the third power, many students get confused that 3 is the power. But in actuality, when we're talking about definitions and vocabulary, this entire piece is the power, where you include both parts of this number and exponent. This number, the 3, is just called the exponent. Not to be confused with saying it's raised to the third power, and that, like I said, that's a common misconception. Let's get that notation there. And then you go, well, what is this? Well, this is called the base. The base. So we have the base, we have the exponent, and these two pieces together make up the power. And oh, I'm so sorry, I got a little bit of blurry there. So look at it again, my hand got in the way. So we have the base, we have the exponent, we have two parts here. The whole thing together is called the power. Just to reiterate that now that it's not having some focus issues. Now, what does this mean? Well, it literally means 5 is going to be multiplied together 3 times. And that sounds confusing. So how do we write that? Well, first we're going to write 5 3 times. 5, 5, 5. And I know they're not evenly spaced. That's okay. And then the operation will always be multiplication between them. So 5 to the third power, or 5 cubed as we call it, is 5 times 5 times 5. Again, we're using our newer form of multiplication. The dot that we just wrote is the same thing. It is equal to what you usually write as in multiplication x. Because we are going to be going into higher level math in the next couple of years, we're going to go ahead and try to convert from the standard x for times, and we're going to switch over to dots. That's my preferred. Sometimes you'll see them in other methods, but especially for exponents such as this, that's how we're going to write it. Now, as we continue down this idea, let's write another one. Let's do 2 raised to the 6th power. So the way I remember this is that I need to write the number 2 6 times. So it's going to be 1, 2, 3, 4, 5, 6. And in between each, we're going to put a multiplication dot. Okay, now we've not solved either of these. At this point, we're just trying to say, okay, how do we write it? How do we put it in what we call expanded form? And I'm going to write that down here. These are expanded form when we write them out as individual pieces to be multiplied. So there's another term for us to remember, okay? So we have a vocabulary term here, here, and here. These are a little harder to define. It's more of like labeling the cell in science. It's hard to explain sometimes, but you know where they're at. So think of those as the same thing. We have our base, our exponent. Together they make the power. When we want to take our power and put it in expanded form, we are going to take the base number and write it the number of times the exponent says. So in this case, 5 to the third is going to be 1, 2, 3. And we're going to put our multiplication between them. 2 to the 6th power means we're going to write 2 6 times. 1, 2, 3, 4, 5, 6. Put our multiplication in between. That is how we do expanded form, okay? Now to solve them, this can get a little bit trickier because they multiply up very, very quickly. Let's look at our 5 times 5. We know that's 25. That is also called a perfect square. 25 is what we call a perfect square, because when we look at it, it is the same number multiplied by each other. Anything that's raised to the second power is a perfect square. I just wanted to highlight that so we remember another one of our vocabulary words. Okay? Now, what do we do next? Next, we have to consider the last 5 that's in there. That last 5 has to now be multiplied by the 25. So it's going to be the 25 multiplied by the 5. And I know that everyone knows how to do the math on this. It's going to be 25 times 5. And if we're just doing a math problem like this, the x is fine, just to clarify. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. So this will equal, and I know I'm getting kind of slow, slide on space, but 125 is going to be the answer to 5 raised to the third. So that is your answer. Remember, I prefer all answers to be boxed in to make things just a little bit easier to find when I'm grading papers. Just a good practice to have. I know a lot of the 7th and 8th grade teachers do the same thing. So I just want to set you up for success there. Okay, 2 raised to the 6th is going to be no different. I like to do it one at a time. So we could do 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So your final answer for 2 raised to the 6th is 64. And that seems so big for such small numbers. We only put 5 down 3 times and it got up over 100. We did 2 6 times and we got up over 50. That's a very big jump. And this is the reason why I say you've got to be very careful with your math, very mindful of what you're doing, and write it out clearly so you don't get confused. This is why I like to draw lines. Now, we could have done 2 and 2, 2 and 2, 2 and 2 for 4, 4, 4. We could have done it like this to get 16. And then we could have done 16 and 4, which still comes out to 64. It's just 2 different ways you could have broken it down. I prefer the bottom one because usually these smaller numbers are easier even if this number gets bigger. Because I don't know how many of y'all could quickly do 16 times 4, but 32 times 2 is a lot faster if you're trying to do it in your head without writing out the long multiplication. So for those of you that needed a quick refresher on how exponents went, this is the breakdown for exponents with a little bit of explanation on some of those vocabulary terms that we've been working with.